All right, so now you have raw car part data arriving from all the factories. Can you use it as is, or do you need to transform and enrich it for subsequent stages?
Good question. The raw data this company ingests isn't too useful as is. So first, they need to run automated processes that clean, transform, and enrich their datasets to make them useful for reporting, analysis, machine learning, and other engineering solutions down the line. In the next demo, we'll be dealing with data that represents a new experimental motor that one of their factories produces, and it will need a little bit more of their attention. Additional information about customers that had the specific motor installed in their car will be added. Data such as customer name, address, age, their geolocation, as well as vehicle model and ID. This will enable them to perform a more fine-grained analysis in the future. So, in this data lifecycle stage, we'll focus on data wrangling, filtering, and enrichment for downstream processing. We will also schedule ETL jobs, so we can optimize resource allocation and showcase job monitoring that allows teams to pinpoint any issues or slowdowns. All of this will be done in Cloudera Data Engineering, which builds upon Apache Spark that allows them to load, transform, and enrich their datasets. What's more, it has a built-in workload orchestration to automate these pipelines at scale. The demo will also illustrate how easy it is to go from streaming, the previous demo, to enrichment and data pipeline automation, this very next one, all in an end-to-end data platform such as CDP. All right, let's see Cloudera Data Engineering in action.
Hi everyone, my name is Shruti Mohan and I'm a solution engineer at Cloudera based out of Frankfurt, Germany, and I get to walk you through the data engineering step. In our electric car vehicle example, we've already gotten the data ingestion done and dumped our raw data into our Hive tables using NiFi and Kafka from the collect step. So the first thing we're going to do in our section here is to pull this data from the Hive tables. And this data is going to represent this new experimental motor that one of our factories has been producing. So the purpose of this is to prepare the data that we've already collected via our ingest step, add it and aggregate it and enrich it with the data sets that we already have on file from historical sets, and bring it together in a way where it's filtered and enriched and meaningful so that future data scientists could then take advantage of the prepared data and make calculations to try and understand exactly where the different experimental motor parts have gone throughout our customer index. And we'll be locating them with exactly their latitude and longitude based off of some geo zip code data that we have already in our historical section as well. So the first step that we're going to be going through here is to use two different Spark jobs to set up and recreate the situation of our enrichment data, historical data sets, right? So we're going to create a couple of data warehouses for that purpose, and then go into the enrichment states of joining, filtering, and making those into a combined data set that's going to be then accessed for the other purposes and activities they're on. I'm looking now here at my first data engineering page, and this is what I would see that my admin would have prepared for me already. A cluster that's been enabled for my environment with an X number of nodes and compute capacity and memory capacity. And within that, a virtual cluster here just for my needs for this specific electric car vehicle purpose with its own separate allocation of quota and restricted resources from within the larger enabled environment here. So if another colleague of mine or another team member wanted to come and create a different use case specific job ingest step, they would go ahead and most likely be creating their own virtual cluster for this purpose if they have a purpose different to mine with the electric car example here. The first thing we're going to have to do in order to access and interact with this and submit jobs here is a step that I've already gone ahead and done, which is going into the cluster details and taking this jobs API URL, downloading the CLI tool, and making it prepared so that we can be interacting with this environment here and submitting jobs and creating resources directly from our CLI. So when I go into the View Jobs section, the first thing I'm greeted with are a couple of three different tabs that are the most important aspects of our data engineering tool here. we see a list on the left-hand side of our existing job runs. Of course, we haven't run any yet. Our existing jobs haven't created any yet. And here, the first section where we're going to create the resources, in this case, the Python scripts that are going to be used in the creation of these jobs. So here's my CDE CLI. I've gone ahead and already prepared the steps so that we can create the resource for our first step, which is the setup data warehousing step. Because I've already added in my config file step where I have included in the jobs API URL, all I'm being asked for is the workload profile password corresponding to my user and the environment that I'm in. The username that I'm in with is Mohan. And the first step that I've asked to then now here do is to create this resource, which is what my previous command has allowed me to do after the CLI has checked to make sure that I actually do have the right permissions. With the view password check, it's allowed me to continue and make that action. And following on with that, I'm going to immediately go ahead and create the next resource as well, which is the enrich data step. So now we'll have both of those created and ready to go so that when we want to move into our job stage, I'll just go ahead and in the meantime quickly add in the uploading of the files specific to our Spark jobs here. And from that, we'll be able to go on and create the jobs themselves. The two scripts corresponding to our setup data warehouse and enrich data steps are what we're seeing here. The create data warehouse steps creates these historical data sets for our simulation pertaining back to the factory information, car installs, experimental motors, marketing data, etc., and makes these available to us in these 5 data warehouses so that for our enrich data step in this next script, we're able to come in and with a import Spark session and PySpark, that's what we're using right here into accessing our data warehouse, connect into the tables in Hive, read those out, add in filters if necessary. For example, we don't want to look at any of our data sets here that include drivers less than 16 years old because that's just not very relevant or reliable data for us for our purpose. And then from there on forth, we're going to combine and join these data with the existing enrichment historical data sets that we created in the previous step. So having said that, those are scripts that I already have locally created. And I'm now going to, in this next step, upload them both into our resource files that we've created. So as we've seen here, in this first step above, I've already gone ahead and uploaded our pre-setup data warehousing Python script. And now in this step, I'm going to do the same for our enrichment data ETL script. These were the ones that we were just looking at in VS Code. And now with my command line actions to upload these into the corresponding file resource directories, we'll see that each of these directories has now been populated with the corresponding Python files that we're going to use for our job creation step. So now that those resources are available to us, let's go ahead and create our first job, which is setting up these historical data sets for our simulation exercise. So I'm going to name this job setup data warehouse. It's a Spark job because this is the Python script that we were just looking at. I do also have the option to create an Airflow-based job, though, if that would be my preference. In this specific use case, it's not. So we already have our resource created, right? So we're going to go into the setup data warehouse resource, select my specific pre-setup data warehouse Python file, and Python default version 3 makes perfect sense for this. I actually don't want to use any of the advanced options in this use case, nor do I want to schedule it. I want to just manually create and have it run immediately. So let's let that sink in and run through for a little bit. And in the meantime, we're going to be doing the same thing with our next enrich data step as soon as this comes to completion. We could schedule it to be dependent on one another, but that's another step for the future. Let's wait for this to complete and revisit. So we've now let and have run both jobs setup data warehouse, which has set up the historical data for the next step, the enrich data job run to also use in order to be able to filter out, combine, and join the tables that are going to be relevant for our electric car vehicle use case, where we're looking for exactly where our specific motor vehicles have gone, experimental motors have gone, I'm sorry. And so the next part of this, and maybe a little quick clarification on how I got this enrich data step running, was again through the CLI. Could have used this UI for it, but I chose to do it in this case from here. I immediately was also responded to with a job ID number, which corresponds to the job its run ID number itself as well. So for each of these jobs, when I click on the run ID, of course, the point of there being a different job runs and job section is that for each job, there could be multiple different runs or instantiations of the job itself. So that's what we're looking at here. There are a couple of different tabs for us to be introduced to. Configuration shows us exactly what we had put into the job. If there were other dependencies that we'd added in jar form, that would have also shown out here for us. In the log section, we basically get to see all of the events as they're occurring. Helpful also if we're trying to make sure that the job that we have started to execute here is actually successfully running or not. The more interesting section is perhaps from here, beyond the typical Spark UI parts that you would see in a normal Spark submit, an extra part specific to CDE, which is the analysis step. So we get the different stage numbers to completely understand, was there any actual scheduled wait time where there's multiple jobs hitting the single virtual cluster, and we need to perhaps introduce more resources into it. Of course, that's not the case here because I'm a single user and I gave myself quite a bit. But there was still a little bit of task schedule wait time, and this is all of the metrics below are what help us kind of explore and look into why that was happening. So speaking of, we see a couple of different metrics here listed around executor total memory, bytes read, input bytes read, etc. But this run deep analysis button allows us to have another job submitted. It's going to give us a bit more information on all of these parts of the Spark submit job that we're looking at. So when we hit run deep analysis, what happens is that in the back end, we see this running as a separate job using the Cloudera Safari user credential here. And what it's actually going to do is the job will run, but the effect that it will create is once that runs to completion, back into the analysis section here. When this is complete, we'll see a few more metrics pop up. In the meantime, what I would like to do is also show you guys the lineage that was created behind each of these Spark job runs that we had submitted. So of course, this is based off of data that was collected in the ingest step and combined with some historical data available to us as well. So when I click on that, because of SDX's connection, making sure and tracing everything going on, that specific job run is shown to me as a part of the process of all of the steps that have occurred before it and the experimental motors table that has been created as a result of it. So interesting bit to follow through here. And now let's go back to our job run here. In the meantime, another thing I wanted to show is that with our REST API access also available to us beyond just what's available in the CDE CLI itself, we're able to also, with a couple of environment variables set in for the purposes of showing exactly which jobs API URL we're going to use, same thing like how we did it for our CDE CLI access. I had to just do a quick curl command and I was able to see the standard out for the last job completed, which was the enrich part. So from our REST API access as well, we're now able to go in and see exactly which tables were joined. What did that output look like? Get a little sampling of it before, as that job is in the process of completion itself as well. As I mentioned, the run deep analysis step here has run to completion. And back in our original job for which we ran this deep analysis, we see quite a bit more further pieces of information listed around what is the actual storage memory distribution, is there heap use memory distribution. And we can see here that this is increasing throughout the processing of this job itself, and that there are lots of parts where there's sporadic increases and peaks for the Spark core usage. So this is all provided to help us understand for the next run of this specific job, when do I want to go into my configuration, for example, and perhaps try running this with a different set of executors and memory that is going to make my job a bit more performant. And all of this is, of course, for that same preparation of the data table that we're seeing here created in Atlas, which is the experimental motors table, which is an aggregation of the historical data sets that we created in our first step in the setup data warehousing step, alongside the ingested data that came in from NiFi and Kafka, pulling and extracting from there via Apache Spark, and allowing us to create something in an aggregated, meaningful format with reliable, relevant data after having filtered through some things that are less meaningful, for example, those drivers under 16 years of age, And once we've submitted it through the multiple different ways of accessing this UI or CDE, CLI, or even later, as we saw with the REST API access, we were able to get a overall overview of all of the jobs that are going on. The corresponding resources and jobs themselves can be reused multiple times over. And with the run deep analysis stuff, we're also able to go in and see a couple more metrics to make all of this further performance too. So summing it up, here we have a fully data engineered environment for doing all kinds of Spark job submits, and doing that also in a performant way and easy to use way from whatever interface makes the most sense for you guys. Thank you.
Hi, I'm Sean Amanian, Product Manager at Cloudera. As we saw in the previous demo, Cloudera Data Engineering makes deployment, testing, tuning, and monitoring of Spark jobs easy and agile. And the first-class APIs makes automation very simple. But we know that creating an end-to-end data enrichment pipeline is not a one-person task. Data engineering is a team effort. It requires collaboration with a common playground to develop and test jobs. It requires defining multi-step pipelines with dependencies and triggers. A single job is generally not enough. And all this managed efficiently with cost in mind, yet at scale for production-sized workloads. Let's take a closer look at how Cloudera Data Engineering addresses these. First, as a platform admin, I want a way to onboard new teams. It needs to be fast, cost-effective, and secure. The overview page within CDE gives me that 10,000-foot view of all the CDE services across all my environments, multi-cloud, AWS or Azure, on the left here. And on the right are the virtual clusters associated with each of these services. And the key benefits that they provide are the ones that we just outlined above. First, it's fast because CDE uses serverless Spark, backed by Kubernetes. Onboarding a new team, for example, our sales team, is as simple as filling out this wizard, and within a matter of minutes, we have a virtual cluster up and running. Now, that's because there's no hardware that needs to be provisioned or procured, and no complex yarn queues to be managed. Now, we have our research and development virtual cluster here, and we'll notice that the resource usage lines are going up and down. And this is the second key aspect, which is that our virtual clusters are auto-scaling for cost efficiency. Administrators can set guardrails along CPU and memory, and we can also, for additional cost management, use AWS Spot instances, which gives us AWS infrastructure cost reduction of up to 90% of our compute resources. And lastly, developers can be added to the user-based access control. This gives our administrator security and governance over the virtual cluster and the associated compute resources, while it lets our developers collaborate as a team. So let's jump in to see how our team of data engineers can collaboratively develop their pipelines. Now with CDE, it's very easy to develop our pipelines in a modular fashion. Earlier we had seen sort of a single job. Now you can see multiple jobs coming from different sources of data. So we have forecast parts data, we have data coming from SAP and MDM. And using CDE's single pane of glass, it's very easy for me to actually troubleshoot and monitor this job. I have access to the historical executions, looking at the trends to spot any anomalies. I have configuration snapshots, a centralized view of all the logs associated with this job. And if I want to look under the hood to see what's happening within this job, I have our visual profiler, which breaks down our Spark job into stages, and it correlates it along metrics like CPU and memory. This allows me to quickly identify bottlenecks and tune performance. Now, given the successful runs of my jobs, I'm pretty confident things are working as expected. What I need to do next is actually take these Spark jobs and sequence them into a pipeline that runs automatically on a regular basis. So in talking to a lot of our customers, they have mentioned that Apache Airflow allows them to speed up the development of pipelines. And that's where CDE's managed Airflow service can help us. It's as simple as this Python configuration file to create our pipeline. We use operators like the one you see here to run our Spark jobs within CDE. It's as easy as writing 3 lines of code. It abstracts away all the complexities of security and integration while giving me all the out-of-the-box benefits such as retries, SLAs, and alerts. I just specified the name of my Spark job. So here you'll see we're calling our customer MDM. And I've specified a retries of 3 times. I'll do the same for all the jobs that are inside my pipeline. And at the very end, I'll sequence them in any logical order that I want with the dependencies. And that's it. I can jump back to CDE's job creation wizard. And previously you had seen us running our Spark jobs through this wizard. But now we've added a new job type called Airflow. I can come in here and specify this as our vehicle pipeline. I'll upload that same Python configuration that I just showed and simply hit create. CDE takes care of registering my pipeline with Airflow to start running based on the triggers that I specified. And Airflow manages the orchestration, retrying the job if there are failures within the pipeline and sending me alerts. And I can monitor this Airflow pipeline like any other job. I have access to the trends, the configuration snapshots, the logs, and I can even look at the Airflow UI that's embedded, which gives me a nice visual way to monitor the progress of my job. So here, I can see our customer data insurance claims actually running, and once they're finished, we'll have it triggering the rest of the sequence in my pipeline. Pretty awesome, right? Now you might be asking yourself, we have our Spark jobs configured, tuned, and running. We have sequenced them into a pipeline. But what about Hive jobs that we typically see with ETL pipelines? And that's a very good question. It's a common pattern we see at our customers. And we usually see this with warehousing use cases with business intelligence, where we run a Spark jobs that are doing complex transformations, but then there are some steps, additional steps required within the warehouse to develop marts and additional modeling. And that's where CDE's managed Airflow service really shines. It allows us to tap into CDP's multifunction analytics to orchestrate a mix of workloads, which includes Spark and Hive. It's as simple as coming back to our Airflow pipeline or the configuration file you saw earlier, and we simply add our Hive jobs into this. So here you can see we're creating our materialized view. That's our Hive query that we'll be running. And using our new CDW operator, we can securely run this Hive query within CDW's auto-scaling virtual warehouse. Again, it's a few simple lines of configurations. I have my virtual warehouse endpoint. I have my Hive query that I'm going to be running. And then we'll simply add this at the bottom in our sequence pipeline. So here we're adding it at the very end as a dependency on 2 other jobs. That's it. We can come into CDE. We'll upload this pipeline, which includes Hive now, and we'll monitor it in the same way as we did before. We have access to the run history and, of course, the embedded Airflow UI. And what we'll see is our final sequence pipeline, which includes the running of Spark jobs. And once they're finished, we'll run our materialized view creation within the virtual warehouse in CDW. That's as simple as you can get. We now have a fully automated pipeline using both Spark and Hive, loading our data prepared and enriched into the virtual warehouse. This can be used for reporting, as we mentioned, using our our data visualizations, or downstream analytics like machine learning. That's the power of CDP's integrated platform. Let's recap what we just saw. CDE is built on the foundation of serverless Spark on Kubernetes to allow for fast auto-scaling and better utilization of resources. And while scale is important, CDE at the same time allows for cost management through quotas and spot instance support to reduce cloud infrastructure costs by over 90%. Onboarding new teams is very fast and easy, with agile development for developers to deploy, test, and tune their jobs. And with a fully managed and integrated Airflow service, teams can orchestrate and automate end-to-end data pipelines with dependencies and triggers without the typical management overhead. And all of this, most importantly, is seamlessly taps into CDP's multifunction analytics. Like you saw, we ran Hive queries in CDW, and we can run models in CML. That's why CDE is purpose-built for data engineers to productionalize their data pipelines at scale. And we're extremely excited to have you build your pipelines with your use cases and let us know what you think.